is from a building control viewpoint. Our building control surveyors, we have to have a particularly broad knowledge of all things relating to construction and the scope of the building regulations. So we can't be specialists in everything. And you know, this presentation is about what I would call the need to know stuff that shapes our decisions on whether a building is compliant or not compliant with the regulations. And it's based on a series of presentations that I deliver internally to our surveyors. So without further ado, the subject is problematic ground conditions, and the focus is on the common problems that we encounter in this region. So you're going to be disappointed if you were hoping to hear about coal mining subsidence or coastal erosion. I won't be covering that, I'm afraid, not in Hertfordshire. What you will hear about is the legislation that's relevant to ground conditions and foundations, the problems presented by shrinkable clay subsoils, the rare but serious problems created by solution features, how radon gas affects development in this region, building control's perspective on contaminated land, the challenges of building on field ground, and a very little bit on sulphate attack on concrete foundation. So I've mixed a few photos in there of our people in action. I see my colleague David Eggleton there looking like he's inspecting a bomb crater rather than a foundation trench. Let's hope he doesn't approve it. Right, start with the legislation, the dry stuff. On the left of the slide, you see an extract from Schedule 1 of the Building Regulations 2010, which are enabled under the Building Act of 1984. And that requirement A2 there, ground movement, is relevant to problematic ground conditions, the subject. The building shall be constructed so that ground movement caused by swelling, shrinkage or freezing of the subsoil or landslip or subsidence, insofar as the risk can be reasonably foreseen, will not impair the stability of the building. Now remember, approved documents are not the building regulations. Along with British standards and other accredited publications, they just give guidance on ways in which compliance with the requirements can be achieved in common building situations. So that doesn't preclude other solutions from being adopted, but in law that would tend to suggest non-compliance with the regs without some sort of other evidence to back them up. Also relevant to the topic today, requirement C1 and approved document C, particularly C11, which you see there, says that the ground to be covered by the building shall be reasonably free from any material that might damage the building or affect its stability, including vegetable matter, topsoil and pre-existing foundations. And 2 there, reasonable precautions should be taken to avoid danger to health and safety caused by contaminants on or in the ground covered or to be covered by the building, and any land associated with the building. So we're outside the footprint of the building now. So much of the regulations is only covering the building itself, but here we're actually covering the gardens and the whole plot. So something to note there. Right, first of the problems. Let's get stuck into shrinkable clay, not literally, I hope. In Hertfordshire, we've got a great variety of natural subsoil types. Makes life interesting for building control surveyors. We find chalk, sand, gravel, different clays, silts, peat, what we sometimes call hogging, which is a sort of mix of gravel and sand bound with a small amount of clay. And apart from the peat, you wouldn't want to build on that. Most of them are quite well suited to being loaded by building foundations, depending on the bearing capacity. But clay soils present unique problems. Clays and silts are cohesive. In other words, they comprise small particles bound together by electrostatic forces rather than friction. And they can be prone to volume change. And that's if the water content varies. I'm going to go into that more later. Site test for clays, because we often find certainly a building surveyor's clay is very different to a builder's clay. The test I would usually use is you can roll it into a ball, it will hold as a ball in your hand and will still retain its shape as a ball if you plunge it into a bucket of water. So if it will do that, then it's clay. If it breaks up into a lot of pieces, then it's probably not a clay that we would need to worry about. So what's the minimum depth we should accept for compliance in a clay soil? And I know my colleague Rachel has put you all on mute, so I'm imagining I can hear, even though I'm right in the wilderness of Buckinghamshire, all these people shouting out, "A metre, Trevor, it's a metre." Well, is it a metre? Not necessarily. These are the minimum depths subject to there being adequate bearing capacity. And in clays, that depends on the particular soil's volume change potential, which is established by testing to find the plasticity index of the clay. And the plasticity index is an indicator of its tendency to shrink and expand with moisture content changes, and that's why it's relevant to minimum depth. More later on that subject as well. So if in doubt, if we look at a soil and we can't tell without testing, then we would always assume it's high. So we would look for the minimum 1 metre depth in a clay soil. So those who shouted were right to an extent. But if it's a medium plasticity, as you can see, 0.9 metres is the minimum, and for low plasticity clay, 0.75. I'll tell you more about those categories, high, medium and low, later. Off topic for a bit, but for non-cohesive soils, what a lot of people don't realise is that 450 millimetres is the theoretical minimum depth. So, you know, you don't necessarily have to have that metre in your head when you've got a nice rock chalk or a real firm gravel or hogging or something like that, especially if you're extending a house and that's on a shallow foundation. The other rule, of course, is some people know, where we're looking at extension foundations, we'd look for them to be to the same depth as the existing house if they're deeper, and that's a good practice just to avoid any risk of differential settlement. And that's created when soils at different levels have different bearing properties. So a bit of background, let's get into a bit of science about this, because I want to hopefully teach people something they don't know. If there's a lot of clever people out there who know all this stuff already, and I'm teaching you to suck eggs. When you analyse soil to determine its properties, you can do what's called a sieve test, and that determines its particle sizes. And it analyses the distribution of particle sizes in a particular sample. So we don't often see that carried out for small domestic work. Nobody can really be bothered to go to that sort of length to design a simple scheme. But occasionally we do, and we can base decisions on foundation design on these results. So the graph there, I'm just going to bear with me while I try and I can get a pointer up here, which will make it easier to describe. Hopefully you can see that bouncing around on the screen. So first thing to say is there's a logarithmic scale there, ranging from 1,000 millimetres on the right to 1 micron on the left. And there are increments of thousandths, hundredths, tenths of millimetres. So that's thousandths, hundredths, tenths of millimetres, millimetres, tens of millimetres, hundreds of millimetres. Just to explain that, it's quite hard to get your head around a scale like that. And then at the bottom, we've got the categorisation of the subsoil types according to particle size. So you've got clay there up to 3 microns, then silt up to 100 microns, sand to 3 millimetres, and so on and so forth, right up to great big boulders, which we're not really concerned with today. So the blue line there on the graph shows the percentage of soil in a sample that's retained by a series of sieves, decreasing from 200 millimetres grid size down to a few microns, i.e. thousandths of a millimetre. So all of the sample, 100%, you can see there, passed through the 200 millimetre grid size sieve. But at 14 millimetre sieve, we can see that only 91% of the sample passed through, and going all the way down through the sieve sizes, nothing then passed beyond what you would call the coarse silt zone there. So in this sample, and that's, what is that? That's about 0.6 of a millimetre there. So no clay in this soil, not a problematic soil, you'd think, which is ironic because this actual result came from where there'd been subsidence caused by an oak tree, and it turned out that this non-problem soil was overlying a highly shrinkable clay. So another sample told a different tale. But enough anecdotes. Let's move on and see the tabulated results of that test. What you do there is move down column 1. There's the sieve sizes all the way down to 3.35, then go to 3 and go all the way through there to the end. That's it, tabulated. All a bit scientific. Why do building control need to know all this malarkey? Well, just take a note there. I've highlighted that 0.425 millimetre or 425 micron sieve, where we see that 18% passed through. So that's the sort of fine sand and clay and silt particles. That's the stuff smaller than that that's getting through that sieve. And I'll show you the relevance of that a bit later. So visually, this would be a sandy gravel, not a problem. So if you're not aware of it, here's a useful tool for establishing the prevailing ground conditions, getting an idea anyway that can be expected in an area. In other words, am I going to have a problem with, do I have to worry about trees? Am I going to have a problem with shrinkable clays? And this is the Geology of Britain viewer. It's available on the website of the British Geological Society, which you can see there up there on the screen, the web address there. And it shows the superficial or drift deposits of subsoil. So I've just picked a map there, and that shows Welwyn Garden City. Right in the middle there is our base, Hertfordshire Building Control, just there. And you can see we're in a formation called Lowestoft Formation or Diamicton. Not a lot of people know what Diamicton is. I didn't till I looked it up a year or two ago. Apparently it's a mix of stones, sand, silt and clay. There is one problem with using these maps in that geologists divide soils and rocks according to their age, not necessarily the type of material it is. So, whether it's sand, clay or rock. So you could take a soil maybe described as something like the Reading Beds, and depending on where that is in the country, it might vary between pure clay, where you've obviously got potential for problems, but in other parts of the country, it may be a sandy soil with no risk at all. So that's where it's, local authority building controls, local knowledge can be handy. Our surveyors, they've got their turfs and they know what the ground's like, and they can help to interpret those maps. And also we can refer to records of countless thousands of inspections carried out over decades on foundations in the towns and cities we live in. And we can see if you're extending a house, what happened up the road and what ground they hit. So, we can be a useful resource there for you if you need it. Also available as a phone app. So isn't everything these days. Right, on to more practical matters relating to foundations in clay. As I say, we've got lots of shrinkable clay subsoil in the southeast. So it's the main problem we probably face in building control. Sorry to teach suck eggs, but better mention that obviously if clay dries, it will shrink in volume. So if a foundation is bearing on the affected zone, then there is a risk of localized settlement or subsidence, which will cause potentially structural damage or cracking. Conversely, if the moisture content increases, as would occur if a large tree was removed in proximity to a building, the tree's no longer taking up the moisture level then will return to equilibrium, i.e. increase, and then you've got a risk of increased volume, heave, creating an uplift pressure on any foundations that are bearing in that zone. So we have to take the risks seriously and guard against them at both the design stage and the inspection stages. Different types of clay have a varying propensity to change volume as a result of an increase or decrease in the moisture content. And the table above there shows guidance based on the property called Modified Plasticity Index. And you'll see that if it's over 40, then that's high volume change potential, medium is 20 to 40, low is 10 10 to 20. What exactly does modified plasticity index mean then? It's such a critical factor in determining foundation depths. Well, let's firstly start with what's plasticity index. Plastic, i.e. it's the point where a material is no longer fluid, and it's the range whereby between it being a fluid and then being plastic and then becoming so crumbly it can no longer be moulded without breaking up. I didn't explain that very well. It went better at rehearsals, but hopefully you get the point. I mean, it's the range of moisture contents whereby you can mould a material without it being fluid or crumbling and breaking it. Interestingly, the lower plastic limit, the point at which it will crumble, is measured by the Atterberg test, which is a very strange test. I thought it was a spoof when somebody told me about it first time. And it's actually rolling little sausages on a piece of glass, and you roll those out until they will not, measuring the thickness until they start crumbling. At that point, then they're no longer plastic, and that would then you would then calculate moisture content, and that would be the lower plastic limit. Anyway, enough digression. That's the plasticity index, but then we're talking about modified plasticity index, aren't we? And we base our decisions on that. So what's that about? There you go, it's on the slide. It's defined as the plasticity index multiplied by the percentage of fine particles passing through there it is, the 425 micron sieve. That was the one I asked you to draw attention to. So all that, the sort of the grittier material, that all helps a material be less shrinkable. So if only 45% of particles are passing through that 425 micron sieve, and we've got an original plasticity index of 60%, then the modified plasticity index is 60 times 45 divided by 100, i.e. 45%. So we're now only got 27%. So you'll understand how critical that is. That can make a big difference on a foundation design, putting a subsoil into a lower risk category, meaning foundations can be substantially shallower and saving cost and inconvenience. Hopefully that's clear. Modified plasticity index. I'm being even-handed here. I'm not being too local authority orientated. There's the NHBC warranty, which gives some guidance on foundation depths in clay soils, as does LABC's warranties technical manual. And they're the industry design guides that we refer to work out suitable foundation depths. And they're accessible to everybody. They're free online, and anybody can refer to them. And you can design to either. We would accept either as a basis for a design. They've actually evolved on the basis of foundation failures, so they're as accurate as we can get them. Both very similar formats. As I say, you give recommended depths based on the modified plasticity index of the clay and the position and species of trees in proximity to the buildings. Both available for free online. I've already said that. If we don't have the benefit of tests, then we have to make a judgment on volume change potential, and we would always err on the side of caution. So if in doubt, assume high shrink. That said, we're fortunate to have an excellent site investigation company on our doorstep, and I'm going to mention them because they're very, very helpful to us, and they let our graduates go up there and have a look. This is Herts and Essex Site Investigations at Standon. So I'm giving them a plug for helping with our graduate training. And they can do a test on a sample of clay soil and very quickly and inexpensively give you the modified plasticity index to base your foundation design on. And that test may only cost as little as, for one sample, £50. And if that classifies a soil as medium or low volume change, or even no volume change potential, it could save a customer an absolute fortune on the extra cost of excavations, muck away, and concrete. So, often a builder will rub his hands and say, oh, I don't mind digging a bit, I've got to get some extras out of this, but it's the client who will suffer in the pocket. So this is a way we can help our clients. Just to quickly show you a typical table in the guidance. This one is for high shrink soil, so that's where the modified plasticity index MPI is over 40%. And this one covers high demand trees, because as you probably know, some trees are more thirsty than others and present more problems. Oaks, willows, poplars, eucalyptus, all high demand trees and in the highest risk category. Even little hawthorns actually were now included in the high risk category because they were found to be causing problems. So yeah, you don't want a hawthorn hedge near your building. A question often comes up, what height do you assume if it's an immature tree? Well, obviously it's going to grow into a mature tree in time, so you take the mature height. So then the question is, all right, I'll take it out. What happens if I remove it? And the rule in the guidance there is that you take the mature height anyway, unless the tree being removed is less than 50% of its mature height. So you look up its mature height. If it's smaller than 50% of that, then you would take actual height at removal when you refer to the tables. If it's more than 50%, then you might as well not take it out, because you're not helping yourself in terms of getting a shallower foundation allowance. You'll note from that table we've got an upper limit of 2.5 meters depth. Anything off that scale is outside the scope of this sort of guide, and you will need to get a structural engineer involved to design a solution. Obviously, there is always options to remove trees, and then you can carry out tests for desiccation or drying out of the soil at founding depth. So, you know, that can also save money, because if you take the tree out, you dig down to a depth and you find the soil is not desiccated, so there's no risk of heave occurring, then you're okay to found at that depth. But again, you would need a laboratory test to determine that that's the case. If what normally happens is, once you go off the scale, then people will err towards using a pile and beam foundation, which needs to be engineer designed. Rafts, not really a good idea. The differential forces that will be applied under that raft by heaving and subsiding subsoil are hard to predict and design for. Our in-house engineers certainly don't like them used in that context. But you may know that in the design guidance, the national design guidance, there is an option to use a raft, but then you have to excavate out, I think, to about 50% of the design depth and replace with a granular material. So that's a very expensive solution that most people wouldn't be bothered with, but it can be done if you want to. Heave precautions, because depth of dig is not the only consideration that we have to worry about, as any movement that occurs in the upper levels of the foundation could also cause a problem, especially if it's an uplift force. There may be sufficient friction between the sides and the swelling soil to lift the foundation, and this might occur when a large tree is removed close to the building. So the diagram there is showing a rather lovely and perfect typical detailing to deal with that risk. We can see the compressible lining there on the inner face to within 500 millimeters of the base of the foundation. And that's usually required on foundations that exceed 1.5 meters because of tree proximity. Funny story, but I can remember somebody going down 1.5 meters because of filled ground or some other reason, and just had it in his head that you always need anti-heave linings. Of course you don't, unless it's for a risk of heave caused by tree proximity in clay. Nice vertical sides there. Why is that important? Any angle created by a collapsed side is going to prevent the lining being put in place properly, and it's going to seriously reduce its effectiveness. So you always need to form straight sides, and if the side's collapsed, it should be shuttered and then relined. And of course, we're seeing in the diagram there a suspended floor system, usually beam and block floors, of course. Also good practice where foundation depth exceeds 1.5 meters. So a regular question we discuss at Hertfordshire Building Control, and I test our graduates with, is do we need anti-heave when you know, say a site of a new house where there's a landscape scheme to show some new trees being planted, some saplings, in a position that dictates that the foundations need to be deep and possibly deeper than 1.5 meters. And everybody says, well, yes, of course you do, Trevor, because you're over 1.5 meters, you need anti-heave. Well, in this case, I would suggest, and it's my opinion, and I know it's not always shared by everybody around the country, but if when the house is built, the moisture content is unaffected by trees, i.e. it is in equilibrium at the time of construction, then if those trees grow, they will remove water from the subsoil. And if they are ever removed at any time in the future, the subsoil will only ever return to equilibrium. So I don't feel there's a risk of heave occurring in those circumstances, and personally wouldn't be looking for heave precautions. So if you ever get a situation like that, you can argue that one yourselves with the building control. And don't mention my name. There you go, that's Claymaster, which we all recognise, pink, low density, expanded polystyrene. It's a compressible lining. It's not a void former. It compresses to effectively relate to a void, but it doesn't actually form a clear void. This is the most common material. It's very brittle. It's horrible to use, really, and it floats well, as lots of builders will know. It floats well in concrete if you don't nail it to the side of the trench very thoroughly. And the warranty guide gives minimum dimensions for anti-heave precautions, and also for subfloor clearances, so that an adequate ventilation zone under the subfloor, which you might know is 150 millimeters, so that we can maintain that even if heave occurs in the subsoil post-build under the floor. So we see there that in a high volume change potential soil, we're looking for a void dimension against the side of the foundation of 35 millimeters. Now, if we're using a compressible material, you have to double that because it will compress, but it's not a void. So, in other words, you'd be looking at 35 times 2 equals 70 millimeters for high volume change potential clays. Conversely, medium, you're looking for a 25 mil effective void, then you would look for 50 mil if using a compressible master type material. Low shrink soils, as you see, you don't need any anti-heave. It's not seen as a risk. This quick diagram to show anti-heave on a pad and beam foundation. These are sometimes used in preference to a continuous strip. Save a bit on muck away and excavation where you need a deep foundation. Just dig bases and bridge between. So you'll note that in this case you put anti-heave lining on all sides within 500 millimeters of the base. You'll also note there's some very robust anchorage of the ground beam into the bases. And we've got void former also under the beam. As per that table in the previous slide, we're looking for 150 millimeters of void in high shrink soil under a ground beam. So you're not really going to use Claymaster there because you'd need 300 mil of the stuff. So you're better off using something like that. That one's, don't want to plug them, but that's the one I always see on site. Chloride Attack, expanded polystyrene again, a void former. So it's commonly used underground beams in pile and beam foundations. It supports the weight of wet concrete, but will crush under load from below. So if there's any heave, it will crush up and you won't transmit load to the floor or ground beam or whatever it is. Clayboard is another one rarely seen. Some of the old boys watching out there, I can see a few of you saying, yeah, I remember that stuff. I haven't seen it in years. It's still made apparently, and it's made with like a cardboard egg box between two impervious sheets. So it will do the same job as the Chloride Attack. And then after the concrete is set, water is introduced into the void where the cardboard is, and that softens it, and then it will decompose away to leave a 100% void. So yeah, I don't think they'll be in business much longer unless we start seeing it on site. Right, that's shrinkable clays. So have a slurp of tea. I'm going. And we'll go on to the next topic. That was the biggest topic, so you might be glad to know that, but the others are a bit more short and sweet. This one is solution features and swallow holes, also called dissolution features and sinkholes. How do they form? Well, different ways, but the natural method of formation is where you might get a concentration of water flowing off an impermeable clay strata, as you see on the left there, and that maybe percolates downwards through the permeable drift deposits, so maybe gravel, sands, into the bedrock chalk at depth. The chalk may dissolve, forming fissures and then cavities, into which the upper deposits may drop down as they grow, these cavities forming over thousands of millions of years in the chalk. And then eventually you might get a subsurface void, and then when that collapses, an open surface void or crater. And obviously that's not something that you want under the corner of your foundations. It can also be caused by unnatural causes. So you might get them where you've had filled ground, so settlement of organic biodegradable material such as buried refuse. And a good example of that was the headlining case experienced by some of my colleagues at St Albans Council in 2015. And there it is. That's a swallow hole in Fontmell Close, St Albans. This one was a man-made feature that resulted from Victorian landfill that was put into an old clay pit. Fortunately, the houses were on piles, so they weren't badly affected, although I think the residents had a bit of a shock, to say the least. Plasticity Building Control having to deal with it. Yeah, that's just a different shot to show that feature. And that's a schematic just showing there's the old clay pit in the purpley colour that was filled with refuse. And the subsequent investigations revealed that there was also a collapsed void in the chalk underneath the pit, which may have been the primary cause. And you wonder if maybe some of the acidic runoff from refuse was probably was dissolving the chalk and exacerbated that problem of a natural cavity in the chalk. Who knows? So there are sort of what you might call hot zones. They're not very hot. They're warm, really, zones in Hertfordshire that Building Control are aware of. The two I've got on the map there are Seal Farm, Hertford, which is over on the right. I wonder if I can get my pointer going again. Let's have a look. No, let's try that again. Yes, got it. So there's Seal Farm over on the right, where we've had a few spring up, and you can see this is the geology map, and it shows those superficial deposits to be sandy, gravelly subsoils between the alluvium of the river valleys. And to the left there, Panshanger, which is across the border into Welling Hatfield territory. And there's another area where you get these features occasionally popping up, and we have to take special precautions. And that's a simple map for the bedrock, as you'd expect. It's chalk, chalk, and more chalk, i.e. soluble limestone, where these things can occur. So what precautions can building control take? Well, we can insist on careful site investigation in where development takes place in these known risk areas. Certainly we would recommend use of dynamic probing to test for subsurface soft zones and cavities in proximity to the proposed footprint of a building, if it's close to where features have occurred in the past. We'd warn designers to watch out for the risk. And of course, when our people are on site checking the foundations, they know to look out for any signs of problems. There's sort of policies adopted over the years. In Welling Hatfield, they looked for, and we still look for, cruciform reinforced concrete foundations when you're extending properties in the brisk zone of Panshanger, and that means you extend the corners out in both directions of the foundations, so that if anything does open up, there's every good chance that it will bridge over and not affect the building. In East Herts and Seal Farm development, we used to insist on thorough site investigations to show there were no features in proximity to the buildings. And that's the Seal Farm map showing the red dots as where features occurred that I was aware of, swallow holes. And just to put the risk in context, these were incidents that we were made aware of over a period of about 15 years. So, they're not exactly a major issue, but when they do occur, they do cause serious problems. Note that one there. I'll show you a picture of that. This is a case I had to deal with as a dangerous structure a few years ago in Seal Farm area. It was caused by a swallow hole. The owner heard a bang in the night, he said, and he came outside in the morning to find this. So this just happened overnight. And yeah, there's no bricks missing. That is literally the corner of the foundation and footing has fallen off the building and dropped the best part of 300 millimetres into a swallow hole that opened up. It may be there was a drain adjacent. It may be that drain had been leaking. And that's what activated the hole. Very difficult to deal with. We had to evacuate the property and haul it off, and eventually it was demolished. It was just a write-off. It couldn't be sorted out. So we look out for those, and the other thing I haven't mentioned is we would look for surface water drainage to go to mains for a change rather than an infiltration system like a soakaway, because that can cause, exacerbate problems with solution features in these sort of ground conditions. They also happen on our new turf, as some of you decorum agents watching might know. This one, February 2014, there it is, a big sinkhole opened up in a suburban road in Dacorum Borough Council. This was Oatridge Gardens in Hemel Hempstead, and it caused apparently 17 houses to be evacuated. Well, that was a big one. That was quite a reaction. There it is. I've managed to pinch some rather grainy images there for you to look at, but quite a startling result there. I look at the picture on the right, which is a terrible picture, but I don't know if anybody else has got a guess at what the foundation type is, because it looks like a ground beam, but I can't see a pile there. And it's got a very clean side, as that also looks like a raft as well. So if anybody was involved in that or knew anything about it, I'd be very interested for an email to tell me what that foundation was, because the building seems to be faring pretty well considering it's hanging over a void. Anyway, that was solution features. We're already on to our next problem subsoil condition, which is radon gas. Radon is a natural, colourless, odourless, radioactive gas. It's formed by the radioactive decay of small amounts of uranium that occur naturally in soil and rocks. And the gas can move upwards through cracks and fissures. Shame on me. I'm presenting a presentation and I forgot to put my phone on silent. It's disgraceful. I will definitely give you some money to charity. Where was I? Yes, small uranium decays to form radon. Eventually it moves upwards through the fissures and cracks in the soil into the atmosphere. Most of it there will disperse harmlessly, but some will pass from the ground and collect in spaces under or within buildings. And in fact, for the average UK resident, apparently radon accounts for half of the annual radiation dose that's received by us, some of us. And it's the second to smoking, it's the second most common cause of lung cancer. So we do have to take it seriously. Until recently, we didn't have to say we had to take it seriously. We didn't have to take it too seriously because the levels on our patch, if you want to call it that, were so low as not to be anything to get concerned about in terms of precautions. And we knew that because we could refer to the free online map that you see there at ukradon.org. And then recently, when we included decorum into our partnership, we had to adapt our policies. And here's why. And this shows our Hertfordshire Building Control patch on the maps. The lighter yellow you see there relates to areas where there's a 1 to 3% risk of radon being present, i.e. a very low risk. And the more orange zone you see on the left there, around Berkhamsted, I've got my pointer, yeah, still got my laser, there you go. The orange zone is showing a risk of between 3 to 5%. So it's only very localized. It doesn't mean that radon's definitely present. It's about the chance of it being present in high levels. So what, as an agent, you can always get the owner to pay for a risk report for their specific property that's available from ukradon.org. And I think it's only a few pounds to get that. And that will give you a more accurate estimate of the risk. If you want even more accuracy, you can send away, I think, £50. You can get a test kit, and they'll send you a couple of little black biscuit-sized detectors that you just expose in the property for a few weeks and send them back, and then they will give you an exact reading of whether there's any radon present. So if we've got no better guide to go on, then we would always look for basic radon protection where the risk exceeds 3%. So in that orangey zone, that's why we're going to be looking for extra measures. Question has come up recently with one of our partner architects. What if the house has been extended? Maybe the existing house is or isn't got any protection to it. Why should we worry about the extension? Well, all the guidance does say, the BRE guidance document BR211 and approved document C both say that extensions should be covered. If there is already protection to the house, then the detailing for the extension must link the radon barriers for obvious reasons. So you can put sealing over at the joint for contiguity of the area. Here's that national guidance I mentioned. Lots of really useful information about detailing to provide a basic level of protection. And that's, as I say, what we look for when the risk exceeds 3%. And don't forget that in other parts of the country, not so far away, there may be a higher risk that looks for an enhanced full protection measures. And there you might see features like subfloor sumps, continuous ventilation using fans. So we have to be careful. We do a lot of partner work nationally in other parts of the country, and we have to watch out for our colleagues around the country letting us know that the issues do exist on their territories, so we can pick it up on our plan assessments. Northamptonshire is the closest that's particularly prevalent for radon problems. So if you're dealing with anything in Northamptonshire, check those maps. It's very quick and easy to do. I'll just go on to show you a few examples of basic radon protection. They're not great examples technically. I think definitely a scientist rather than an architect drew them up. Here we see a suspended concrete floor. Usually, of course, the floor level would be close to ground level. You know, we've got to comply with Part M. So that's a nice detail that wouldn't always be practical. And obviously, with a lower floor level, then you might have the problem of ventilation ducts to that subfloor having to pass through the membrane. Fortunately, products are available whereby you can see around any periscopes penetrating the membrane in the cavity. Here's a barrier laid over a ground bearing slab. Simple there, very simple, doubling up as a damp-proof course. No, it's not damp-proof. Obviously, we need a separate damp-proof course. A radon barrier wouldn't necessarily be appropriate for that function as well. Nearly slipped up there. With all these solutions, the sealing of joints and laps around joints and the laps around penetrations through the membranes is really critical. It needs to be gas tight, obviously, and that's usually where building control will find the problems. Whether it's radon gas or any other gas membranes, it's the fine detail of the sealing that goes wrong, and that's why it's a key stage for us to be notified for inspecting this stage in the job, so that we can go and check that before it's covered over, when it's a contaminated site, of course. Here's an option where the barrier is laid over the ground at low level. There it is, out to the perimeter of the building. Again, not the most practical detail. What a fiddle. You've got a sand blinding, then you've got a radon barrier, then you've got more sand blinding, then you've got some hardcore with some more sand blinding. You're going to get rid of a lot of sand on this job. Then you've got a DPM and insulation and slab. So there's lots of ways of skinning the proverbial cat, and you know, the manufacturers of these membranes will give some more practical guidance on how to install them. Of course, just briefly to mention that radon is not the only gas we need to worry about. As part of dealing with contaminated land, we also come across problems with methane and carbon dioxide. And I don't know, like me, a while ago, you think, well, carbon dioxide, you know, it's full of it, isn't it? Why do we have to worry so much about that? Well, then, you know, if you watch the Apollo 14 film, Apollo 13 film even, you remember that they nearly scuppered their mission because the capsule was filling up with carbon dioxide. In fact, some of you may know, but only 0.4 of the atmosphere is made up of carbon dioxide. If it gets to a level of about 5%, then it's fatal. So, you know, it is a toxic gas potentially, which we have to worry about and protect the health of building occupants. So guidance on those subjects, there's another BRE document, BR414, and all of these available from online databases if you're hooked into them, if you subscribe to them. And if you don't, then that's what Hertfordshire Building Control are here for, you know, to help support you, and we've got access to all this guidance, and we can pass it on for specific projects. And that can be pre-submission, of course. You don't have to wait to make an application to talk to us. Right, on now to talk a bit about contaminated land. It's a very big topic. It's a topic on its own, really, and that's why I'm trying to set up with a very good company to present in more detail on the subject. So today I'm going back to the point I made. This is need to know building control stuff rather than the finer science of the subject. So let's give you an idea of the considerations and procedures that we think we should take as part of assessing a scheme for compliance with that requirement C1. And the Building Regs 2010 is one of several pieces of legislation for dealing with contaminated land issues. We've also got approved document C. But before that comes into play, there's also part 2A of the Environmental Protection Act. And our colleagues, the planning officers at the district councils, can generally consult with environmental health as part of the process of processing a planning application. And they can attach planning conditions preventing work commencing before an assessment has been undertaken and any necessary measures agreed. So in some cases where there are known and documented contamination risks, the issues might already have been covered in the planning process by the time it comes to submission to us in building control. But we do often receive applications for new housing where contamination has not been properly considered, and we have got a duty to apply the guidance in approved document C. There it is, approved document C. And what are the steps that we need to take? Well, there they are in 4 phases. Phase 1, desk study and site survey. So that's where we look for a preliminary risk assessment to be carried out to obtain a good understanding of the site's history, its setting, and its potential to be affected by contamination. A bit of further reading there for anybody interested, that's BRE Digest 348, very old document, but still current. And there's another one that would cover the sort of site walkover and the desktop study. Sorry, I got that wrong. The one there covers the walkover study. There's another digest that covers the desk study. So, slowly back into here and carry on. So if you're carrying, when we're checking a scheme for a sensitive building, so by that I mean a residential building, a house or a school or a nursery or something like that, then we need to ensure that the applicant has at least undertaken that phase 1, and that will identify the need and scope for phase 2 being taken as well. That's sort of like a dependent one. And phase 2 being the more intrusive investigation. And there you'd expect to see targeted trial holes, targets shaped by the result of the desktops and site survey. And also some sampling for chemical analysis and testing. So we're now getting into, specialists earning their corn. Phase 3 then would be the remediation on the basis of a planned strategy with appropriate monitoring taking place. And then finally, phase 4, we would look for a verification report. So that might include retesting of the soils to be absolutely certain that everything's been either treated or removed. We'd also look for a statement from a suitably qualified person that the remediation work is completed and has been effective. We can't issue our completion certificate until we've got that. All those phases are carried out and documented. And as I say, it's a specialist company that needs to do it. That we would be scrutinising their credentials to make sure we think that they're up to the job. This is what we have to bear in mind when determining the risk to people occupying buildings. It's the very simple schematic showing a contaminant pathway receptor linkages. And this is in approved documents, see this particular diagram. In other words, how could people come into contact with these harmful substances that might be present in the soil? So it could be from contact with the soil in the garden. I mean, that child licking the lawn there, if there's anything nasty in there, it's not going to do him any good. It could also be via food grown. They've got some nice little allotment going there that could pick up the toxins and then be brought into the house via the food. Could be inhalation of dust. It could be contamination of the water supply. In some cases, you've got contaminants that necessitate not us, but the contractor using special barrier piping to prevent any contaminants entering the water supply. So we look to the consultant to propose how they're going to mitigate against these risks. In other words, they're looking to break the pollutant linkages. And he can do that by various methods. Treatment, which might be biological treatment, chemical treatment, or some sort of physical technique. Containment, which might be encapsulation of the hazard, putting some sort of a barrier over it, adding layers to achieve separation from the receptors. Usually horizontal, but it might also be vertical containment to prevent migration of the contamination to other areas. Or it could be removal, and I think that's quite a common one to see. In other words, just excavate and cart away the contaminated subsoil to a suitably registered landfill site, and then the problem's gone. Retest the soil at the end, and if it's clear it's all gone, then we're going to be happy and replace it with something from that's also been tested and found to be clean. Greenfield sites, there's another lovely picture. And you look at that and you think pure as the driven snow, that sort of building plot. Not that you can get a building plot like that in Hertfordshire, I'm sure, but if you could, you'd look at that and you say, yeah, that's lovely. Or maybe it might be a back garden, you know, some back garden development, infill development and lovely lawns and things like that. One thing I've learned over my career is never to make assumptions that there's no contamination. Building control would always, at least where it's one of these sensitive land uses, would always at least ask for that phase 1 assessment. So, you know, we wouldn't let it go without that, and then that should justify whether or not you go on to the second phase and a more intrusive investigation. So I'll give you an example of a greenfield site for a dwelling a few years back that I dealt with. And yeah, it was a beautiful field with horses grazing, but when they did the desktop survey, it revealed that the former land use was horticultural glass houses. And that triggered some more intrusive testing, which showed that there was some real serious contamination caused by the long-term use of pesticides and fertilizers, along with a load of broken grass just underneath the surface topsoil. So, you know, even things like that and back garden development, as I say, can reveal contamination present. You know, things like buried refuse, leaking oil tanks, years of bonfires, Victorian properties. You know, they used to burn everything in those days, or bury and dump it. So they didn't, you know, have very good refuse disposal systems. So yeah, the point there is don't make assumptions. To help with that desktop study I mentioned, we've now got free, easy access to historical maps. Some of you might know about this. This is a website, National Library of Scotland, and you can look at various Ordnance Survey maps from the last 150 years to see what land use has taken place over that time. There's an extract from it showing my old hunting ground in East Hertfordshire, Wallfield House, headquarters of East Herts Building Control. It was. Google Maps is another useful tool for looking at proposed sites for development. You know, I know a lot of our people sometimes will look at them to see what the tree presence is like, if we know it's a clay soil, and then also you might get an idea if trees have been recently removed. Just a bit of a case history here. In this particular slide, you'll see the circled area in red. This was a housing development just off the A1170 near Ware. And the subsoil, and I was the building control surveyor looking at the foundations. Subsoil generally good, natural gravel, nice and compact. But an area of fill was encountered at about 1 metre deep on one of the plots. And it was this one I seem to remember, although it's a distant memory. And it was comprised really deep deposits of a very soft, light green, soapy material with an unusual odour. So work had to be stopped while this was analysed. I can say now that if I'd had access to those historical maps at the time, which I didn't, I might have expected some evidence of a past use. Because if we look on the same site on the Ordnance Survey map from 1914, we can see there that long, narrow building turned out to be a rope works. And the material that we'd dug into was tallow, of all things. It was dumped tallow, i.e. sheep's fat, and that had been used in the production of rope. Apparently, it's put into rope production. So fortunately, pretty harmless stuff, and wouldn't do much harm to anybody, but it's certainly not the sort of thing you want to put a load from a foundation on. So these maps can be useful in advance of development. They can show things like old gravel pits, industrial uses, ponds, all things that might trigger you to think, well, let's do a bit more intrusive investigation, see what we're going to hit, rather than find out when the machine's on site and it's far more inconvenient to stop work. So that's all on contamination. And as I say, I am trying to put together another online CPD event on this topic in conjunction with a company called STM Environmental, who do a lot of work with our planning colleagues. So watch out for an invitation in the next couple of months on that particular subject. But we're going to go on to quickly just cover filled ground. What's to say? It's an excavated soil, loses its compaction. that it's got in its natural state. In other words, when it's excavated, it bulks up. Some soils bulk up more than others. So that means its bearing capacity is reduced. Sometimes it's made worse by other deposits that are mixed in. It may contain organic deposits that are slowly biodegrading, may contain contaminants that are harmful to health or could potentially damage the building. Building on fill basically creates a risk of large differential settlements. So the norm is always dig through it down to natural strata. If in doubt, just dig through it until you hit the pay dirt. On the slide there, just another BRE publication on the subject for some bedtime reading for anybody who wants it. Quite a good publication there. How do you spot it? Sometimes it's very difficult. Our people look for colour changes in the sides and bottom of the trench. When you see a contrasting band of colour in the bottom or sides, and that always tends to suggest there could be some unnatural geology there. And then we might ask the builders to give us a sample to break into a sample of the soil to look for unnatural inclusions such as bits of brick and tile or burnt material. As soon as you're seeing stuff like that, you know it can't be natural soil and that it's probably worth digging a bit deeper. Of course, back in the day, as a young, foolish sprog surveyor, I always used to jump down the trench and have a dig. We don't do that anymore. That's very bad thing to do unless the trench is very thoroughly shuttered. But you can have a prod from the surface with a spade, and you will, I know a lot of building control surveyors develop a knack for feeling the ring of a good soil as against the puddingy thump of a field soil. So that's always a good thing to do. And you can get a contrast by going down through the entire run of the trench. The most common field problem we come across is soakaways, because where we're dealing with the domestic extensions as we do, most houses have got soakaways out the back, and that's exactly where people are extending. So we always look out for those, and we look to deepen the foundation through any fill that comprises the soakaway, and also, of course, just importantly, to divert the soakaway to a new location, because we don't want rainwater to continue to be pouring into that area. Obviously, we also look for manholes and access chambers to work out where the drain runs might be, so we can make sure that the foundations go below drains and that they're bridged over. And we check sewer maps on every development. We'll look at what we call the DigDat map, which is produced by Thames Water Utilities. Not all drains are on there, obviously, only the registered public sewers, but they'd be helpful. We also find a lot of old wells, houses, homes of a certain age, from the sort of 18th and early 19th centuries. You often find wells. They may be dumb wells, or what are called soft water wells, whereby they're maybe 3 or 4 meters deep. They've been used as just a storage container for rainwater that was then pumped up to do the laundry and things like that, and then obviously they've become redundant and been filled over, so that they can be found and need then to be capped and backfilled and bridged over, occasionally necessitating an engineer if it's not a simple bridge. And of course we've got natural wells, of course, which also sometimes we have to get them filled and bridged. Filling natural wells, always use something like a reject stone, something that's not going to clog up the aquifer at a lower level or contaminate the aquifer. Finally, the way we would spot fill ground, as I said earlier, look at the historical maps, look for those pits and ponds and quarries where fill ground might be present. Did I mention about checking the sewer map? That's a startling photo, isn't it? Thanks to my colleague Les Ryder, who took that image. Yeah, I'm not quite sure if it's quite as bad as it looks. I'm not quite sure that the building is bearing on that huge culvert or sewer, whatever it is. But it's a funny picture. You never know, it might be. In which case, it's doing a good job because there's no cracks in the building so far. So if you don't have access to these maps, which most people don't actually, because they're a bit tight with releasing the access, we do, and any of our customers can give us a call and we'll happily check the maps and let you know if there's a public sewer on the land that you're going to develop. And that, again, in advance of submitting an application. So I said don't build on fill, dig through it, but building on fill can sometimes be feasible subject to design. And I'll give you a couple of examples. In the picture there, ringed is Foxholes, an estate near Hertford. It was built on the site of a former gravel quarry that was backfilled with selected fill, which was mainly hogging, good stuff. And then it was treated by a process called dynamic consolidation. And simply put, that's dropping a dirty grey metal weight from height onto the ground to compact it and improve the bearing capacity. Now, due to the risk of localised soft spots, in case they missed anything with the weights, we look in this particular area for precautionary reinforcement to the foundations on extensions. So just a simple, relatively light cage that's then dowelled into the existing foundation before concreting. So further details of that, talk to your building control surveyor or give us a call and we can talk you through that if you ever build it, get work in that area. And just a couple of really grainy images. That's a dynamic consolidation rig on the left and vibroflotation on the right. Vibroflotation being another process that was used at that Foxhole site. A vibrating poker dropped into the ground, then reject stones poured in, poked down, vibrated down to, again, consolidate and compact the soil and increase the bearing capacity. Yeah, very bad photos. Occasionally we find that some types of untreated field ground can be built on, lightweight development, single story. If the ground is inert, reasonably well consolidated, so it's quite old fill, then maybe it can be founded on, bearing in mind it's probably got a very low bearing capacity, so you're going to need to spread the load. You might do that with a designed raft foundation, because obviously that will spread the building load over the footprint of the building rather than just over over a strip foundation. But as I say, that's only where you've got inert fill that's reasonably consistent. It's a funny one. You can work out what that is. It's a not so good example of a raft foundation that was encountered by an LABC colleague in another authority in the country, and that was made up from cut up shopping trolleys. I'm pretty sure he didn't pass it. But, you've got to admire his innovation there. And, whilst his foundation was failed, the good thing was the local canal was thoroughly cleared out. So, there's always a bright side to these things. Finally, we're on a roll towards the conclusion now. And after me droning on all this time, you'll probably breathe a sigh of relief at that. I thought I also briefly mention the issue of sulphate attack. And that occurs when sulphate solutions, and they can be derived either from the aggregate in the concrete or from external sources such as groundwater. They can react with the calcium aluminate hydrates that's present in hardened cement to form a substance known as ettringite. Ettringite occupies twice the original volume of the material. So as you can imagine, that expansive force can inflict serious damage on concrete, leading to weakening and sometimes failure of the affected structure. Now, this is different to chloride attack. Chloride attack usually affects the reinforcing steel and causes it to corrode badly, and then the concrete will spoil from the corroding steel. And chlorides are usually introduced by contaminated aggregate, in other words, salts in the aggregate. But we don't get that problem very much, so I'm not really including it. So most soil investigation reports will include a test for sulphates being present. It doesn't prove to be a big problem in this county, and in my experience, it's quite rare to see a sulphate problem raised on a soil report. but it is encountered more in areas with London clay, and also in areas where there's the galt clay. So maybe that's Bedfordshire and Cambridgeshire, where they've got a lot of the galt clay. They can have more problems with sulphates and have to take precautions. It's always in a clay soil. You don't get sulphate problems in gravels and things like that. And even then, it's usually only what you'd call a homogeneous brown clay. So in a lot of Hertfordshire, it's the mixed up chalky boulder clays that we find. You don't get sulphates in that sort of clay. And when they are present, they can be seen as small white salt-like crystals. I talked to the guy who tests for these things. He said, yeah, when you cut the clay, say brown homogeneous clay or cut like cheese, you can hear and feel the grit in the clay, which is the crystals, and then they know to test for it. So that is the end of our whistle-stop tour of problematic ground conditions. I hope you enjoyed it, and even if some of it was already known to you, I hope you gleaned at least some useful knowledge from it, so that it was worth your time. Obviously, you've all been muted because we had to get through it. It wasn't possible to answer all the questions as we ran through, but Rachel, my colleague, my Hertfordshire Building Control colleague, Rachel Legood, is listening in and may have been collating any questions. Rachel, was there anything that came up that we could answer now?
I haven't got any questions at the moment, Trevor. The presentation is on there's a chat facility. If you do want to get any questions to us, feel free to email marketing@hertfordshirebc.co.uk, or Trevor, his email's up on the screen there still, and we'll get back to you.
There you go. That's how we'll work it, because I'm sure you want to get off to other things. We'll be canvassing your views on this CPD event, and on the basis of that, we may well produce more events like this, depending on the feedback. Alternatively, when I see the feedback, I might decide it's best to restrict myself to my captive audience at Hertfordshire Building Control, but we'll see what pans out and move from there. So it just remains for me to thank you, those who hung with it. I hope it was useful to you, and that you'll join us another time for future events. Have a lovely afternoon out there in the sunshine, and stay well. Bye for now.